In this lesson, we're looking at normal distributions. When the distribution of data values is clearly symmetric, we say that the data values have a normal distribution. So one of the main things that we do with data values that are normally distributed, we can make predictions about the probabilities of some event happening as it relates to those data values. The first thing that we need to understand in order to do that is that the area up under the curve is 1, and that area corresponds to the probability of 100% probability that of something occurring. Now for a normal distribution, 68% of the values are within 1 standard deviation above or below the mean. 95% of the values are within 2 standard deviations above or below the mean. And then almost all, 99.7%, are within 3 standard deviations of the mean. Now, before calculators and technology, we needed some way to standardize the values that are on the x-axis for a normal distribution. Otherwise, it would require calculus in order to find the area up under the curve. So the way that was done in the past was we standardized the normal distribution, giving us z-scores that we could correlate to a table of z-scores that was usually a fold-out in most textbooks. The way that we calculate the z-score, corresponding z-score to any value for a set of values that are normally distributed, we take the mean and subtract each one of the values that we want to convert to a z-score and subtract the mean and then divide by the standard deviation. All right, in this first example, we want to suppose that the heights of men ages 20 to 29 in the U.S. are normally distributed with a mean of 69.3 inches and a standard deviation of 2.92 inches. We want to find the percent of men that are between 60.5 inches and 78.06 inches tall. Now we know that 60.54 is 3 standard deviations below the mean, and 78.06 is 3 standard deviations above the mean. And we know that from the previous slide that 99.7% of the values are within 3 standard deviations above and below the mean. So almost all, 99.7% of men heights will be between 60.54 inches and 78.06 inches. And then next we want to find the percent of men who are shorter than 60.54 inches. So 60.54 is 3 standard deviations below the mean. So we want to subtract 100% minus the 99.7% of the values that are within 3 standard deviations of the mean. And we get 0.3%. Now there's 0.3% between the two sides of the curve. Left side and the right side together make up that 0.3%. We only want the left side, the part that's below, less than 3 standard deviations below the mean. So we need to divide by 2, and we get 0.15%. For this next example, we want to suppose the heights in inches of women between 20 and 29 are normally distributed with a mean of 64.1 and a standard deviation of 2.75 inches. We want to find the percent of women that are no more than 65 inches tall. That means at most 65 inches or less. So we can convert this to a z-score if we did not have access to the technology, Desmos calculator, TI-83 calculator. We would convert that value, 65 inches, to a z-score by subtracting the mean and then dividing by the standard deviation. And that would correspond to a z-score of 0.327. We would look that up on the table. Again, if we did not have the technology, that z-score for all standard normal distributions, the mean is 0 and the standard deviation is 1. That is the case for all standard normal distributions. So 0.327 lies just above the mean. So we want to find the area up under the curve to the left of 0.327 on a standard normal distribution. Using the Desmos calculator, we would go to the functions and then DIST for distributions, normal distribution, enter the mean and the standard deviation, mean, comma, standard deviation, 64.1, comma, 2.75, and then indicate the left and right boundaries for the area under the curve. As you can see in the figure, to the left it goes forever to negative infinity, and the right boundary would be the actual value, 65. When we're using the technology, we don't have to convert it to a z-score because there's an algorithm that's already in the technology that does the calculus for us. So we just need to indicate what the interval is for the area under the curve that we're trying to find. So the left boundary would be negative infinity and the right boundary would be 65. And that brings back a probability of 0.628. So there's a 62.8% chance of randomly choosing a woman between 20 and 29 and she being less than 65 inches tall or less. Next, we want to find the probability that a randomly selected woman would be between 60 and 63 inches. Again, if we did not have the technology, we can convert those two values to z-scores and then refer to the table. But using the Desmos calculator, again, for a standard normal distribution, the mean is 0 and the standard deviation is 1. So those z-scores, negative 1.49 and negative 0.4, they both lie to the left of the mean. And so we want to find that area up under the curve using the Desmos calculator. Go to normal distribution, indicate what the mean and the standard deviations are, separated by a comma, and then the left and the right boundary. The left boundary for the area under the curve that we need to find is 60. The right boundary is 63. That brings back a probability of 0.277 or 27. Since we're asked to find the probability, we want to leave it as a decimal, 3 decimal places. And then lastly, we want to suppose the heights of adult females ages 20 to 29 in the U.S. are normally distributed with a mean of 64.1 and a standard deviation of 2.75. We want to find the percent of women that are at least 66 inches tall. That means 66 inches or greater. So just using the Desmos calculator, normal distribution, mean, standard deviation, left boundary would be 66 and the right boundary would be infinity. That brings it back a probability of 0.245, and we were told to find the percentage, so converting that to a percentage, we just moved the decimal place twice to the right for a percentage of 24.5%. And lastly, the percent of women that are less than or equal to 61.6 inches tall, normal distribution, mean, standard deviation, less than or equal to 61.6, that would give us a left boundary of negative infinity, and a right boundary of 61.6. That brings back a probability of 0.182, which corresponds to a percentage of 18.2%.